Welcome to my wonderful honors chemistry class presentation. I'm so proud of these kids. We did an interesting study of hydrates, and they are going to present their work.
Alright, so we had the best desiccants of substances which were cobalt chloride, magnesium sulfate, copper sulfate, and calcium sulfate, aluminum sulfate, and sodium phosphate analysis. Can you explain the purpose?
The purpose of the lab was to find the percent of water in each hydrate and determine which substance can be used as the best desiccant based on those, based on the data that we got. All right.
And before going further, we would like to explain the term of the hydrate, which is a solid compound that contains water in its crystal structure, and the second term, anhydrous, which is a property that describes a substance with no water, and the last, desiccant, a substance used as a drying agent.
The criteria for the best desiccant includes a high percent of water, relatively low toxicity, relatively low cost, and availability.
We had to test cobalt chloride and test the different hydrate and anhydrous forms.
Yes, so we took the hydrate, and which you can see was a dark purple, almost maroon color, and you can see the picture of that, and then we burned it on the Bunsen burner until it became the anhydrous form when all the water left, and we found out we were trying to figure out if this would be a good desiccant. So
it's cheaper and easier to find as a hydrate than an anhydrous. And it's about 8 cents per gram in the hydrate form and 74 cents per gram in the anhydrous form. It's found in it's a mineral. Minerals, chloride, and it's pretty easy to find. It's commonly associated with ores of iron and nickel, silver, lead, etc.
It would not be that great of a desiccant because it is very toxic. It can be a carcinogen when in fume or dust, so it's very likely to catch on fire, and it's mildly toxic if ingested, and it can cause blood damage. So you wouldn't want to use that in your house or around children where they could eat it and die. Wait, should I not? Eat it and die. I'm sorry. Sorry.
Okay.
And then you have to have someone licensed that can dispose of it. So that is very hard and it's annoying. So nobody wants to buy it and then have someone else come and dispose of it. And then the only reason it would be a good desiccant is because the percentage of water when we took the water out was 47 to 49%. So that means it was almost half water. That means it has a very high absorbency. So.
Okay, for our slide, we did magnesium sulfate as our hydrate. For its toxicity, it's an irritant. It can cause abdominal pain and it affect the central nervous system and the GI tract if consumed. In the anhydrous form, it costs 6 cents per gram for a 500 gram bottle, and the hydrous form it costs 1 cent per gram. So the anhydrous is much cheaper.
For the disposal information, it's solid waste disposal by landfill, which basically just means you can throw it away, so that's not too complicated. It's pretty widely available. You can just go to Walmart to buy it under Epsom salt, so that's not too hard either.
Okay, for our table of data, sorry, I'm gonna look at these numbers. It's for each of our trials. The average mass percent of water was 43.13%. So about half of it is water. And we came to the conclusion that the anhydrous was more expensive because it was a more concentrated version compared to the hydrous. And that's our slide.
Okay, so our material that we did for the lab was copper sulfate, and in the anhydrous form, when we evaporated all the water that was in it, the color was off-white, and when it's in the hydrate form, full of water, it's like a light blue color, and it has no smell to it either. It's moderately toxic through ingestion and inhalation, so as long as you don't eat it, it won't really bother you that much. But it's also irritating to the skin and respiratory system, so just try to keep it off of yourself if you're ever handling it. And then in order to store it, you just keep it in a Flynn Chem Saf bag, which is a heavy-duty plastic bag that doesn't let vapors or anything, any kind of particles out of it.
And to dispose copper sulfate, you have to put it in a fume hood, which is basically an enclosed area with ventilation. Copper sulfate is easily available, and you can get it over the counter. Per gram in the anhydrous form, it's 9 cents, and then the whole bottle, which is 500 grams, is $43.50. And copper sulfate is produced through the reaction of copper compounds and sulfuric acid.
And we found the percent mass of each one. We got 21% for the first one, 27% for the second trial, 34% for the third trial, and 35% for the last trial. And the only reason we got the differences is because those were the two groups, different percents that they got.
And that's copper sulfate.
Hi, today we will talk about the calcium sulfate, and we just did an experiment and we had learned a lot about it. And so first, calcium sulfate is a calcium salt that we can find a lot in the natural environment, and it is normally in the form of white powder, and sometimes it is crystallized solid.
And there are two primary forms for calcium sulfate. One of them is anhydrous and the other one is hydrous.
Calcium sulfate is non-combustible, and people also use calcium sulfate in industrial manufacturing.
Yeah.
And do you want to talk about? So we did the experiment and we try to heat the calcium sulfate.
Yeah. So we basically heated the anhydrous calcium sulfate, and there was no chemical reaction except that the amount of water within the substance just lowered. It evaporated.
Yeah, and that is pretty much about it.
Hello, this is Danny, Vincent, and Ross.
Hi.
And our hydrate is aluminum sulfate. Exciting. Wow. Well, we had 4 total trials, and our goal of the lab was to get the water composition of the aluminum sulfate. In trial 1, our water composition was 46.8. Trial 2, it was 47.3. Trial 3, it was 46.3. And trial 4, it was 48.3. As you've heard, therefore, our data was pretty accurate, and we calculated this by getting the initial mass and aftermass, after being heated, mass of the aluminum sulfate in the cup in the lab, and after that we subtracted the aftermass from the initial mass, then divided that by the mass of the divided that by the powder mass, and multiplied it by 100 so we could get the percent. Alright, Vincent.
So how much the aluminum sulfate, Ross?
It's generally 2 cents per gram. It's formed in chemical labs. It's toxic to the reproductive system. It's an irritant, so it can irritate your skin if you come in contact with it. It can also damage your urinary system, etc.
Are they explosive?
Yeah, they're pretty explosive.
Yeah. Oh. And any question?
What is it used for?
Oh yeah, it is used in water purification and pain relief for stings and bites. Like when the bees sting you, you can use it to just like get it cured. And also aluminum sulfate that's in temperature greater than 1400 Fahrenheit, and it will decompose, generating toxic gas.
Oh wow, that's very interesting. That's really cool, fun facts, guys.
Yeah.
Ha ha ha.
Sodium phosphate analysis. Toxicity. Now, sodium phosphate is mildly toxic when ingested and can corrode muscle tissue severely. Athletes, however, have been known to use it to increase power by up to 8%.
To dispose of sodium phosphate, it is recommended by the Flynn catalog to put in a newspaper, put in a cardboard box, and then to put in a chemical landfill.
Availability. The lab-grade trisodium phosphate can be bought at Flynn Scientific. The hydrate can also be found in degreasers, dish soap, and stain removers.
Cost per gram of the hydrate when there's water in it is 2 cents per gram. And then the cost per gram of the anhydrates when there's no water is 1 cent per gram.
Results. The percent of water found in trial 1 after heating the sodium phosphate so all the water evaporates was 51%, meaning that 51% of the hydrate form of sodium phosphate was water.
Trial 2, it was 52%, so 58%. In trial 2, there's 58%, so that means that there's 58% in there before we had, what's the name, in trial 2, there's 58%, so that when we had put it, oh my goodness, there's 58% of water in trial 2.
Trials 3 and 4 were considered outliers with 19 and 17%. Therefore, we didn't use them because we found that they were inaccurate and didn't pertain to the hydrate.
That's it, right?
I'm Jack, this is Tim, and that's sodium phosphate. Yeah.
Yep.
After finding the percent masses of water of each substance, we found that cobalt chloride was the best hydrate to use because it absorbed 48.35% of its mass in water.
We also determined that it was also the most expensive of the group, coming in at about 75 cents per gram of anhydrous.
It did stand out in toxicity also, as it can only be disposed by a hazardous waste disposal company and can cause many problems if ingested.
This may not be the best choice for a product for going to small children, though, in which case the runner-up aluminum sulfate might be a good idea because it's less toxic in case the child were to eat it. And yeah, that's basically what we learned in this experiment. Ta-da!